Hello everyone. This is part 3 of the presentation on the course data communication, particularly module 1. So, we are already looking at the transition media, different transition modes. Now we are looking at the electromagnetic signal. So, that is what is communicated over the medium, whether it is a gated medium or ungated medium. The communication is in the form of a electromagnetic signal. That can be an electrical signal or a magnetic signal, or it could be a laser beam, whatever it is. In general, we can view it as a electromagnetic signal. So, what is an electromagnetic wave? Electromagnetic waves are formed when an electric field comes in contact with a magnetic field. So, this is about more electronics part. I just given a definition. Okay, no need to look into more details about how the signals are generated. Anyway, simply understand that whenever an electric field is getting contact with the magnetic field, the kind of waves which are generated are called the electromagnetic wave, and they are hence known as electromagnetic waves. The electric field and the magnetic field of an electromagnetic wave are perpendicular to each other, so that the electromagnetic waves are generated. So, the generated electromagnetic waves are also perpendicular to the direction of the electrical and magnetic field. So, the electric and magnetic fields are perpendicular each other, and they are also perpendicular to the direction of the electromagnetic wave which are generated as a result of the contact. So, just some property of the wave. As a function of time, the electromagnetic signal can either be analog or digital. Now, we are going to represent our electromagnetic signal as a function of time. So, that is actually this is called a time domain representation, and there is no force like you should always represent a electromagnetic signal as a function of time. You can also represent it by a function of frequency also, that is frequency domain representation, which is more popular one, and those details we will see later. As of now, just for beginning the concept of electromagnetic wave, let us see how it can be represented by a function of time. And in that context, you can think of an analog and a digital signal. And you know what is that analog and digital signal? An analog signal is one in which the signal intensity varies in a smooth fashion over time. In other words, there are no break or discontinuous in the signal. So, it is a continuous signal, the signal is always the amplitude signal intensity is nothing but the amplitude, the terms we will see, and it is varying in a smooth continuous manner. Okay, there is no discontinuities or break for the signal. It is moving in a smooth way. When it comes to digital signal, that is the discrete counterpart, is one in which the signal intensity maintains a constant level for some period of time and then abruptly change it to another constant level. So, there will be some 2 or 3 or some other levels, some n number of levels will be there, and it will retain a particular level of signal fixed for a particular duration of time. Then it will abruptly change it to the other signal level, and maybe if there are 2 levels, to and fro, it will change the signal level. So, here you can see a discrete concept. So, the continuous signal might be represented, might represent the speech, and the discrete signal might represent binary 1 and 0. Normally, for representing the information in our computer, that is zeros and ones, we are using this digital signal, that is the discrete representation. But if you are looking at the speech waves and all, they are analog in nature, they are continuous in nature. So, an example, see, this is analog signal, because the signal is smoothly or continuously moving like this, there is no abrupt change. But here, see, it is at this level for some duration of time, abruptly it is changing to this, again it maintains this level constantly for some time, abruptly changing, again for some time this level, again for some time this level, like that. Here you can see a 2 level signal, but you can think of 4 level, 8 level, normally some multiple of 2, like that. But this is a smooth analog signal. Now, there is something called a periodic and aperiodic signal. So, you know, here this is not this is an aperiodic signal, there is no pattern that is just repeating, but if you are looking at a sine wave instead, you know that particular cycle, this cycle is, that pattern is getting repeated, right? That is what is called a periodic signal. So, a periodic signal completes a pattern within a measurable time frame called a period. So, how much time it taken to complete a given pattern, the pattern by which that particular signal is made up of, and repeats the same pattern over subsequent identical periods. So, some say period of a signal means the time which it taken for completing that particular pattern, and after that again it will repeat that pattern, and that how much time it will taken for repeating, that also same. That means at a fixed interval the same pattern is getting repeated, and that interval of time is what we call as a period of the signal. Okay. The completion of one full pattern is called a cycle also. So, how much time it taken to complete a cycle, that is period of the entire signal. When it comes to a non-periodic or aperiodic signal, that changes without exhibiting a pattern or a cycle that repeats over time. So, previously we saw an aperiodic signal where there is no pattern at all to repeat. Okay. So, we are more interested in periodic signal, and mathematically you can define a periodic signal as something like I already told you. Here we are initially we are looking at the representation of the signal as a function of time. So, S is the given signal as a function of time t, that is S of t. So, how you can define this S of t? S of t plus capital T. So, this capital T is, I did not mention it here, it is this capital T is nothing but the period of the signal. That means a fixed interval of time, after that the same signal is repeating, that is why S of t, t is the time, total time, this is the time at which the period pattern is repeating, that is a constant value. T plus t is nothing but S of t, the same signal you can see it is repeating after this. So, this time varies from minus infinity to infinity in general, where the constant t is called the period of the signal. And what is this t? T is the smallest value that satisfies the equation. That means the smallest constant value such that the same pattern is getting repeated, and that makes the period of the signal. Otherwise, if we are not able to find out such a t, then it is called an aperiodic signal. Hope it is clear. So, here you can see some examples. I already told you this sine wave. See this pattern, it is starting from here and it is completing a cycle at this point. So, this part of the signal from here to here, okay, and this part of the signal is called a what? Cycle. And this is a cycle, and the same cycle or the pattern is repeating again. Okay, like that it is going. So, see the representation here in x axis we are taking the time, and in y axis we are taking the amplitude, and this amplitude versus time plot is called the time domain representation of the signal. And the same signal you can represent by another plot called between the amplitude and frequency, and that is what is called the frequency domain representation, that we will see later. But to introduce a concept, it is always better to follow the time domain concept. Okay, so here you can see the amplitude. So, the maximum amplitude of the signal we call it as a peak amplitude, it is say capital A. Similarly, at the negative side it is going up to minus A, and the time is starting from 0. Normally we have a convention like but actually the time can be, in general definition it can be from minus infinity to plus infinity, but when it comes to practical for studying purpose and all, we assume that the signal is starting at origin, that is it is in the positive direction only, like this. Okay, so and this duration of time, how much time it will take for completing a cycle or completing its pattern which is repeating is called the period. And there is another term called frequency. We will see what is frequency, the rate at which a number of cycles per second, something like that we will see, and the relation between the period and frequency is t is equal to 1 by f. This part we will see. Okay, and here we have another, this is an periodic continuous signal or a periodic analog signal. Here we have a periodic discrete signal or periodic digital signal, that is a square wave, which is periodic also. Okay, and here also this makes a cycle from here to here. It's something like it's starting from here, that is not here. From 0 it is starting, just like from 0 this is starting. This, I think this line is missing. From 0 this is starting and it is going and it is ending here. This is one cycle and this is the next cycle, like that. and then this time is again called the period of the signal, and this here also we have the peak amplitude, and the difference is here gradually the signal is reaching the peak amplitude, then it is decreasing, but here that peak amplitude it will maintain for a discrete amount of times. That is the main difference between an analog signal and a digital signal. Okay, hope this concept of periodic signal and aperiodic signal is clear. Now about sine wave, and the sine wave is the fundamental periodic signal. Most of the cases people are studying it and using it. Then a general sine wave can be represented by 3 parameters: the peak amplitude, like what I said, the frequency and phase. Now we will see these terminologies. The peak amplitude is the maximum value or intensity or strength of the signal over time. Typically this value is measured in volts, like in the previous diagram we saw that the peak amplitude A volts, like that it is denoted. The maximum value, in general it is amplitude and that is smoothly increasing for a sine wave, and what is the maximum value it is reaching is called a peak amplitude, and generally amplitude is represented by the unit called volt. And frequency, like what is the frequency of something, some event, like that. So the general definition of frequency, when it comes to a wave, frequency is a rate at which the signal is repeating. And what is rate? Rate means a number of cycles per second. Okay, so we always calculate a rate in unit time. Here the unit time is say 1 second. 1 second, how many cycles are repeating? That is what we call as the rate. Okay, for example, if I am denoting, say, f is the frequency of a signal, what does it mean? I am saying that, say, f hertz is the frequency. What does it mean? In sorry. Oh, where it gone? Okay, I was trying to say something. Say if f is the frequency, that means in 1 second of time there are, say, f cycles. I am taking lot of effort to write this. Okay, f cycles. Okay, in 1 second we have f cycles. Oh, again it gone, sorry. 1 second we have f cycles. So that is the meaning of frequency. Frequency is equal to, say, f hertz, means in every second we have f cycles. Now for a particular cycle, how much time it is taken? That is, for f cycle we have 1 second. So for 1 cycle we have 1 by f second, and that 1 by f second, that is the time taken for a particular cycle, is what we call as the period of the signal. So the period of the signal is nothing but, just understand like this. So this is how the time period and the frequency are related. I am trying to explain this, how this time period is equal to 1 by frequency. The reason is, what is the, just look at the definition of frequency, the rate at which the pattern is repeating. I am saying that, say, f hertz. F hertz is the frequency, that means how many cycles are repeating per second. In 1 second f cycles are repeating. Then for a particular cycle, how much time it will take? That is 1 by f seconds. And that 1 by f second, the time taken for completing a particular cycle is what we call as the time period. So an equivalent parameter is the time period of a signal, which is the amount of time it takes for one cycle or one repetition, and therefore the time period and the frequency are inversely proportional to each other. Hope it is clear. Sorry for the delay. Now the next term, that is phase. This is something you have to give more attention. That is why I prepared separate presentation for it. The term phase describes the position of the waveform relative to time 0. I'm just reading. If we think of the wave as something that can be shifted backward or forward along the time axis, phase describes the amount of shift. So, let me take an example and show you. So, this is something like this. Here I have a sine wave that is starting from here and it is moving like this. X axis I am taking the phase. Sorry, I am taking the time. Now, see, this is a normal case. The actual cycle is starting here and the full cycle is completed here. Now, see this diagram, what is happening here. If you are looking at this origin, the signal is starting at this point, but here it is starting here itself. Okay. So, that is the difference. That means it is going like this and now one cycle is completed. So, what has happened is the total cycle is shifted backward. Okay. So, if you are looking at this as a cycle, this is half of the cycle, right. Now, its half, that is 1/4 of the cycle, and this portion as a whole is shifted backward here, right. That means the total time from here to here is t. Okay. And so, that from here to here the time will be t by 2. So, the middle part from here to here the time will be t by 4. So, that t by 4 or 1/4 into t, that portion of the signal is shifted in the negative direction. So, at the origin the signal is not starting, actually signal started sometimes back and it is continuing, but the signal is actually beginning here only. So, this is not part of the signal. Okay. But that part is missing, something like that, and here you can see that there is a phase shift. So, in this case there is no phase shift, it is fully completing a cycle like this. So, or the phase is 0 or phase shift is 0, but here we have a phase shift and it is normally represented in degree or radian, and the concept is like the total time for one cycle is say 2 pi radians or 360 degree. Okay. So, if you are viewing the total time phase of a particular total phase of a cycle as 360 degree, this half portion will be of 180 degree, its half will be 90 degree. So, actually that 90 degree shift, backward shift happened here. That is why the signal is starting like this. So, this represent a signal with a phase 90 degree or a phase shift 90 degree. Both terms are interchangeably used. But here see, the signal is going in this direction. That means half of it is shifted, or the total time period by 2, 1/2 into t is shifted backward, and the signal is actually starting it from its half only, or the half means 180 degree. So, here we have a 180 degree shifted signal. So, mainly we are looking at 0 degree, 90 degree, 180 degree, but in between you can think of a 45 degree phase shift, 270 degree phase shift, everything. Okay. So, this is main concept. Now, you read it, it will be clear. The term phase describes the position of the waveform related to time 0. If the waveform is beginning with respect to 0, that is 0 phase. Here the position is here, right. This is how the waveform is beginning. Here it is beginning at 0, but it is going in a decreasing way. So, that is what is phase. If we think of the wave as something that can be shifted backward or forward along the time axis, phase describes the amount of that shift, how much the particular signal is shifted, the particular cycle of a signal is shifted. It indicates the status of the first cycle. We are to identify what is a phase, you do not have to look at the whole signal, simply look at the first cycle only, observe the first cycle only. So, phase is measured in degrees or radians, and the relation between degree and radians is 360 degree is 2 pi radians. Accordingly, pi or 3.14 that value, you can convert into degree and radian, you can use this formula that you know, right. A phase shift of 360 degree corresponds to a shift of a complete period, okay, or complete period or a complete cycle is getting shifted, that is 360 degree. Half of the cycle is shifted or half of the period is shifted, that corresponds to 180 degree, and quarter 1/4 of the signal is shifted, that corresponds to 90 degrees. That is what we seen in the diagram. This is 90 degree and this is 180 degree. Half of it is shifted. No shift means 0 degree, quarter shift or 1/4 shift means 90 degree, 180 degree shift means on half of the cycle shifted means 180 degree shift. Okay. Similarly 270, any value you can think. The full wave suppose is shifted, that is 360 degree. Okay. So this part only we are considering, that is why. And some observations, a sine wave with a phase of 0 degree starts at time 0 with a 0 amplitude, and then the amplitude is increasing. Just observe the figure. Here it is a 0 degree sine wave. What is happening? It is starting with a 0 amplitude at the point 0, and the amplitude is just increasing. Okay. But what about a 90 degree phase shift wave? It is starting with the peak amplitude, right? We know for a signal like this is a peak amplitude. So the signal starting with the peak amplitude itself, and that amplitude value is decreasing. That is how you have to understand a 90 degree shifted signal. Now what is happening for a 180 degree shifted signal? It is starting with a 0 amplitude, but the amplitude keep decreasing. Here it is starting with a 0, but the amplitude keep increasing. Okay. So 0 degree, 180 degree. Here it is starting with the peak amplitude and it is decreasing. Okay. That is the first set of observation. A sine wave with a phase of 0 degree start at 0 with a 0 amplitude. Okay. The amplitude is increasing. Okay. Increasing. Here it is starting for 90 degree shift, starting with the 0 time, but means the negative part we are considering. That is why we are always saying starting with the 0. With the peak amplitude we are starting, the amplitude is decreasing. Here with 0 amplitude we are starting, but the amplitude is decreasing for 180 degree shift. Another way to look at the phase is in terms of shift or the offset value. You have to be familiar with the terminology. If they are asking some problems, that is why I am writing like this. A sine wave with a 0 degree is not shifted at all, right? And we already seen when it comes to 90 degree shift, 1/4 of the cycle is shifted actually. The total cycle 1/4, that is 90 degree shifted. 180 degree shift means half of the cycle is shifted. Then similarly the 270 means 3/4 of the total cycle is shifted. So like that you can think, but mainly we are looking at the 0 degree phase shift, 90 degree and 180 degree. So with this I am winding up this part. Here we look at the electromagnetic waves, the analog and digital wave difference, periodic and aperiodic signal, and we saw some more details about the sine wave, particularly what is amplitude, what is frequency, what is time period, how they are related, and what is phase. Hope it is clear for you. Thank you.